on your graph. So you see it as that double bar. It means if you plug in an integer, that's what you get out. Anything else, you get the greatest integer that is less than x, if x is not an integer. In other words, what are integers? Positive and negative whole numbers. So like -3, -2, -1, 0, 1, 2, 3. Those are integers. Those are the only possible y values we can get from this function. Now, you can never get out something bigger than what you plug in. So if I put in 0, 0 is an integer, I get out 0. But if I put in a half, 1/2 is not an integer, but you can't get out anything bigger than 1/2. So what is the greatest integer? Be 0, because 1/2 falls between 0 and 1, you always give me the smaller one. So if I said 0.9, 0.9 falls between 0 and 1, you're still going to get out 0. You can't get out anything bigger than what you put in. So you only get out integer values, nothing bigger than what you plugged in. So if I just asked you to evaluate some of these. If I did the greatest integer of -5. Okay, if you plug in an integer, that's what you get out. So -5 is an integer, so the greatest integer of -0.5 is -5. If it's an integer, that is exactly what you get out. B, if I said the greatest integer of 2.46. 2.46, if you were to graph this on number line, it falls in between 2 and 3. You can't get out anything bigger than what you put in, so we're going to get out 2. Greatest integer of -6.5. The negatives always seem to trip people up, but you guys got it. -6.5 falls between -6 and -7. You always have to give the smaller one, which is the one on the left, so it is -7. Good. Right, any questions so far? Let's graph this. So we're going to graph our greatest integer function. If you remember in algebra 2, I always told my class, if you can get one complete step, then you know what everything looks like. So we just need to get one full step on our graph. So if I make my t-chart, if I put in 0, greatest integer of 0 is 0. So 0, 0. Now, you don't want to just jump up to 1 here. Let's try some decimals. If I put in 0.4, what is the greatest integer of 0.4? No, you're right the first time.
Oh, when it looks like 1.4.
Oh, sorry, that's just my greatest integer bracket. So we still get out 0. So 0.4 is still giving me 0. What if I put in 0.7? Greatest integer of 0.7? Still 0. What if you put in 0.9? What's the greatest integer of 0.9? Still 0.
Why?
You can't get anything bigger than what you put in.
Oh.
What if I put in 1? That gives you out 1. Okay, so when you graph this, you are going to be down here at 0 up until you put in 1. So what we always put, what happens right here? Open circle. So you have an open circle at 1, 0, then you jump up. That is really all you need from your t-chart, because now I can see my steps are 1 unit long, and then you jump up 1. So I'm gonna be on this step from 1 to 2. Grace integer always has a closed circle on the left, open circle on the right, and then I would jump up to my next piece. And it keeps going. You could go the other way. I would drop down, closed circle on the left, open circle on the right. My general rule is I want your graph to show at least 3 complete steps. And then if you just want to put the dot dot dots on both ends to show that it keeps continuing in that pattern, that would be fine with me. Let's answer some of the questions we did when we looked at all of our other functions back a couple sections ago. What's the domain of this? Yeah. And that'll always be the case on the Grace integer function. You can plug in any x value you want. Your range, though, we're not getting out all of the y values. We're just getting out the integers. So you could write integers, you could do the integer symbol, the double barred z, whatever you prefer. You could even just list some. So say dot dot dot, -2, -1, 0, 1, 2, dot dot dot. The dot dot dots just show me it keeps going in both directions, so whatever you're most comfortable with. Alright, is this graph ever increasing? Each step goes up, but are you ever like actually have a line with a positive slope here? Yeah, all of these are constant. So there is no increasing or decreasing. It's just constant on each step. And where is this continuous? In between each step. So really everywhere except the integer values, right? Like between 0 and 1 it's continuous. I can do that whole thing without picking up my pencil. But then at 1 I have to jump. So you could say on each step, you could say everywhere except the integers, something along those lines. So we're going to graph the Grace integer of 1/3 x minus 2. Start by making our teacher. We need to get one complete step here. So probably the easiest thing is to always start by plugging in 0. 1/3 times 0 is 0. Minus 2 is -2. So we get the Grace integer of -2, which is -2. So 0. -2 is a point on my graph. What do you want to try plugging in next? 0.5. Both good options. Alright. we plug in 0.3, 1/3 times 0.3 minus 2. You get negative 1.9. So the greatest integer of negative 1.9 is negative 2. 0.3, I'm still down here at negative 2. If I put in 0.5, 1/3 times 0.5 minus 2 is negative 1.83. So the greatest integer of that is still negative 2. What happens if I put in a 1? One-third times 1 minus 2 is negative 1.67. What's the greatest integer of that? Still negative 2.
So we have 2 by 3.
Okay, why 3?
Because 1, 2.
If you want to get an integer out, 1/3 times what would give you an integer? 1/3 times 3. If we plug in 3, 1/3 times 3 is 1, minus 2 is negative 1. Greatest integer of negative 1 is negative 1. So 3, negative 1. So that's my jumping spot. So I can see each step here is 3 units long. And then you jump up 1.
For this.
So minimum of 3 complete steps on your graphs, and then you can just put the dot, 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 show me it continues. All the steps are going to look exactly the same. It'll always be closed on the left, open on the right. What's the domain of this? And that'll always be for all the greatest integer. What's the range on this one?
3.
Negative 3, negative 2, negative 1. You could list them and put the dot, 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 or say all integers, so either way. Questions on that one? You guys remember doing these before? Let's try it. An express mail company charges $20 for a package weighing up to 2 pounds and $2 for each additional pound or fraction of a pound. Let y equals c of x represent the cost to send a package weighing x pounds. Graph it in the interval 0 to 6. The mail is an excellent example of a step function. Now, if I'm just going to put a letter in the mail, as long as it weighs under a certain amount, I just put my stamp on it. But then, if it weighs too much, you have to start putting additional stamps on it, right? So if it weighs in this range, you pay X amount. If it weighs a little more, you pay this much. That's an example of a piecewise function. So let's look at this one. We are just supposed to graph this on the interval 0 to 6. Okay, my baseline, the lowest they're going to charge me is $20. Then it's going to go up $2 for each additional. So I'm just counting by 2's here. y-axis is representing my cost, the x-axis would be the pounds. Okay. If I go to mail a package, will you ever have a package that weighs absolutely nothing? No. But could it weigh like 0.1, 0.2, 0.3? How much are you going to pay if you drop it in the mail and it is 1/10 of a pound with this company? You're going to pay the $20. As soon as you go to mail it, it's an automatic flat $20. So what we know is it's going to start up here at 20. You'll never have a package weighing 0 pounds. So I'm going to put my open circle here. It stays at 20 for everything up to 2 pounds. So if it weighs half a pound, you're paying $20. If it weighs 1 pound, you're paying $20. If it weighs 1.5 pounds, you're paying $20. If it weighs 2 pounds, you're still paying that $20. But as soon as you hit 2.1 pounds, what happens to your cost? Not to 30. It goes up to 22. So anything over, I'm going to go up to 22. So I'm going to start with an open circle, and so that I can show as soon as I hit 2.1 or 2.2, I'm paying 22. How long am I going to stay there at 22? For each additional pound. So for everything from 2 to 3 pounds, you are paying the $22. But if you hit any 3.1 pounds, what happens to your price? It goes up to 24. And you'll be paying $24 up until you get to 4 pounds. And then what are you going to pay? 26. And you'll be paying 26 until you get to 5 pounds. And then you're going to pay 28 until you get to 6 pounds. Because for every additional pound, we had to go up another $2. What's the domain of this graph? Well, except this one we didn't really continue, did we? This one only went from 0 to 6. Kind of tricked you there, it doesn't. So my range in that interval, we only hit 20, 22, 24, 26, and 28. Because I'm not extending. We were only talking in between those values.
Or even integers.
Between 20 and 28, because since we stopped it at that 6, we're not going to go above. All right. Questions? What I would like to do, we haven't had much work time in class the past few days. I kind of wanted to stop here and give you guys time to work so you can ask questions. If you're good with it, you can just get through the homework, but I wanted to allow some time for individual help here. So I have another handout for you, and then this is your time to get help if you're struggling with anything.